Anybody? Any doubts? Yeah. Browning of fruits is also a chemical change. Why it is chemical change? When your mother will give you a neat and cut piece of apples nowadays we are at the home quarantine and we are staying at home. We are very much safe at staying at home. Okay, we are taking very healthy food to increase our immunity power. Am I right? Are you all doing it, children?
Yes,
you are eating nutritious food, healthy food. Yes, everyone. So when we are eating, so we can observe it. When we get a fresh piece of apples, we'll can see that freshness on the apple and the flavor also very much like tasty. You feel it. So when you leave the apple in presence of air, like open air without closing or somewhat, even though it will close also, okay, so that the apple gradually converts to brown in color. So if you eat that brown color apple, have you feel like any change in the taste? There is any change in the taste when the apple becomes brown? Yes.
the chemical composition changes.
Yes, dear. Yes, definitely. It's the chemical property changes. Why? Because the apple itself consists of an enzyme, triose enzyme. Okay, this enzyme will react with oxygen. Like it's also undergoing corrosion, children. Like how rusting takes place, at the same way some fruits like peach, apple, banana, all this, most of them fruits will undergo this corrosion process, and this enzyme, the enzymes present in it will react with the oxygen and the moisture. Yes, it's like raw taste, like pungent, like odor also will feel sometimes, that strong acidic odor also will feel. Understood? So this taste is because the surface layer is almost reacting with the atmospheric oxygen and the moisture, and it converts its property, chemical composition property. So we won't feel by eating the brown colored apple, like we can't feel the freshness of the apple when we eat it, the brown one, because the chemical property changed. Understood? So browning of fruits also comes under chemical change, children. Simply we can say the rusting of iron, and the same way rusting of fruits is nothing but browning of fruits. And it's also a chemical change. Any doubts? Any doubts?
No, ma'am.
So this is because of the enzyme present in the foods reacts with oxygen. There the metal itself reacts with oxygen and moisture. So here you can find how the fruits become browning. Why? Because this rare the enzymes is easily reacting with the atmospheric oxygen and moisture. Though you closed in a closed container, if it is already consists of oxygen, it becomes brown color. So that what we need to add on its surface, we need to add salt or citrus. Citrus is nothing but acid. When you add a citrus or like lemon or salt, so what happens? It acts like a layer. It won't allow it to react with atmospheric oxygen and moisture, so that will feel fruits fresh. The freshness will feel. Understood or not? So why do you add lemon and everything? Whenever your mother gives the fresh fruits, eat immediately. Don't say no and don't allow the food get brown. Get it brown. Yeah? Every day we should learn, along with the studies, we should go with the values also. Value based. Am I right? Yeah, next. So reaction with iron and copper sulfate. Like how we have seen, I have given you the iron, Fe plus O2 plus H2O gives rise to Fe2O3 dot XH2O. What is this reaction, children? We have discussed so many times in the previous session. So Fe plus O2 plus H2O gives rise to Fe2O3 dot XH2O. When did you find this reaction in the previous section? What is this reaction called? What does it mean? Anybody in the class?
Iron oxide. Ma'am, can you repeat? I did not understand what you said. So, what you said?
What is this reaction called, children? What is this reaction called? Yeah?
Iron oxide.
Dusting of iron. Am I right? Dusting of iron. This is iron oxide. Or iron oxide. This is the thing I want to ask. So this is one kind of a chemical change. It's also another chemical change, that reaction with iron and copper sulfate solution. So see, it's called, this reaction, especially this reaction is called as single displacement reaction. What is this reaction called as? This reaction is called as
Simple displacement.
single displacement reaction. Here you can find that here copper sulfate, which is blue in color. Copper sulfate is blue in color. Take the copper sulfate in the beaker and dip the iron nail into it. So what is the color of iron nail? What is the color of iron nail? Gray silverish. Yes, gray in color. When you dip the iron nail in the blue color copper sulfate, after some time, the solution turns to green color. The solution turns to green color, and we can find copper, the brown color copper deposited on the surface of iron. Brown color deposited on the surface of iron. So let me show you once, and I'll show you the module also so that you can understand.
Ma'am.
Yeah, dear?
Ma'am, we did an experiment in the class this year. So in that they put copper sulfate solution, and in that they put an iron nail. After a few hours, the iron nail, whichever the part of the iron nail, whichever is inside the copper sulfate solution, it became brown. First green, then it became like brownish yellow.
Very good. This is copper sulfate we have taken, which is blue in color. Okay. So what I did, I just dipped the iron nail into it. So what is the color of iron nail? What is the color of iron nail? What is the color of iron? Gray in color or silvery in color. So when I dip it, after some time, this solution turns to green color. Solution turns to green color, that is iron sulfate. And what about this copper? On the surface of iron, here the copper, if you have taken the iron nail outside, you can see that copper is deposited on the surface of iron. Why is it so? Why this reaction takes place? What is the reason that iron displaces? Iron takes the place of copper. Yes, Priscilla? Yeah.
Ma'am, because in the activity series of metals, ma'am, iron is in the top and copper is in the low, meaning iron is more reactive than copper. That's why they both get exchanged.
Definitely, 100% get. Very well. So in our class also, all the children having ability in the class, like all the chemical or what we can say, all the properties of the children are same. But some are active in sports, some are active in doing CCA activities, some are active in doing any other. You want to know about the Priscilla, you are topper in the school, everyone are toppers here. You are answering very well. Understood? Yeah?
Yes. But she always answers everything in chemistry, so I just asked her.
Yeah, no. You answer well. Kumbana also. I had maybe sometimes answer by texting. Good, very good. Okay, so and the reactivity series in the sense reactivity like metals also, like highly reactive metals, the metals which are having ability to react easily. So they'll be placed at the top. Okay, the metals which are reacting moderately, they will be present at the middle. The metals which are least reactive, they are present at the last. So when we have seen in the copper in the reactivity series, the copper is present at the last and iron is present above the copper. So definitely, so this iron is having capability to take place, to took the place of the iron, copper. So it takes the place of copper, and so that the copper will be out of the compound. Out of the compound. It's just displacing. It's just displacing. For example, when we are going to the race, like team race, relay race. So when we are going to the race, definitely the team consists of like a house group children. We are having houses now in the class, different houses. So
Yes, ma'am.
yes, very good. So the child should replace with the same house child. But definitely your team will think to replace that boy, because if he got injured, definitely one more fellow need to occupy that place. So definitely what are the team members think about it? The team members should see that the capability of the replacing that boy with the capability which the other boy should have higher. Expectation is more than the boy who got out of the team. Understood what I mean to say? So definitely what the team children will do, so he'll give the place of the other boy because he is much more confident, or maybe he is equal to the capability of that boy who is out of the team. The same here, metals also. If copper is highly reactive than iron, so iron can't replace it. But here iron is more reactive than copper, so definitely it replaces. So that iron takes the place of copper. Single displacement, what? We are not talking about double displacement here. Why double displacement? You will study the double displacement in the higher class. Here you are displacing copper with iron only. Why sulfate is not changing it, nah? So why to raise that double displacement again? I think some children will feel much more confusion about it. Don't talk about the double displacement. Double displacement, precipitation reaction, you are going to learn in your higher classes. Don't think about the double displacement. We are only talking about the single displacement. Yes? Any doubts? So I want to show you a small video about it. Let's enjoy by seeing it.
Okay.
Yeah.
Ma'am, so in the copper sulfate solution, we mix water also, no, ma'am, in the copper
solution itself. Copper sulfate is in the crystallized form. It's like crystals. Okay, so that crystals we have taken and we are added into the water. Water is a universal solvent, so it easily dissolves the copper sulfate. So it forms copper sulfate solution. Yes.
No, ma'am, not that out. So when we put those iron nails into the copper sulfate solution, doesn't it rust? Because if it goes into water, it usually rusts. So
it's not rusting here. It's not rusting. So when we place the iron over there, the iron will take the position of sulfate, like copper will be out now, so that copper will be deposited. It is not reacting. It is present on the surface. It is just deposited on the surface of iron. The separated copper takes the position on the surface of iron. We can scrap it out. We can scrap it. Few of the iron ions will occupy the place of copper.
okay, ma'am.
Yeah. Anything else?
Nothing.
Anything else?